Hi everyone. We are going to talk today about one MCP to rule them all, how to secure your MCP. A little bit more about myself. So I'm Or. I'm a full stack data scientist at Lasso. I love to build stuff, not only program, as you can see also in arcade machines. And yeah, let's dive in. So our goal today is to understand how we can secure MCPs as a builders and as a users, and how we can distribute this in our company. And we want to know what is the risks and understand better how to manipulate this kind of attacks to help us to build a better security. So we will start with this quote and take a second to read it. It's really amazing because it's meant that almost half of the MCPs that we are using today are contain the command injection flows. In other words, it means that we can run code over them and control them from the client. This is really crazy. And I know, I think it's happened because some gap in the over like half year that come between the builders and the users. So in one part, the builders are the AI engineers, data scientists, backend developers, but not so much security experts. And in the other side, we have a big hype. So the user is like everyone that wants to use MCP. It's really easy to integrate, to install, and start working with it because the clients allow us a lot. So we will start with how we can help the builders build a better MCP and secure them. So the categories I want to focus today for the builders is the authentication and authorization, input validation, and the rate limiting. So if you don't know about authentication authorization, let's understand today. Like it's really important. There's two type of a connection that you want to do with the server. Like the authentication is to confirm that users are really who they are, and the authorization part is what kind of permission or resources that have an access to. And this is really two different stuff that we want to handle. As you already know, there are two types of servers, the STD-IO and the streamable HTTP. One of them is local and another is remote. And if you want to have access to resources in the server and it's local, you can use a simple token. This token will allow you to communicate with a local server and send an API request over the resource directly. But what happens if you are using a remote server? And this server, it's not an official server, so it's a third-party server. You don't want to give your credentials to this server, right? So the server needs to implement something that's called auth. This auth protocol, it's working like this. It's like in a hotel. You have a reception, and the reception gives you a card to the room you are want to go to. This card contains all the information of which type of room you want to go and how many times you will have access to this room. This reception is the authorization server in the auth. After that, you will get an access token. This card access token allow you to enter the resources or the MCP server resources that you are using. And all the control about this access token is coming from the authorization server. So it can stop anytime you want this control. And in addition, it don't identify you. So this access token don't identify you as someone that uses this server resources. Today, most of the server implement the auth and the resources in the same MCP server. So the authorization request and the resource request are happens to the same server. And this is not anyone's fault, but the MCP protocol worked like this like until 3 months ago. This has been changed in a pull request. So right now we want to separate these two kind of call. The authorization request will go to auth server that dedicated to this process, and the resource request will go to your real MCP server, so we can have the expertise do what they know to do and handle the auth in the expertise and handle our server and the resistance and the logic in our server. So with this practice, we can see that right now the flow graph from the client will go to the auth server. And you don't need to understand the details here, but the important stuff is where the I is. The MCP client in the end will send you a JWT token, which means this access token that allow you to access the resources from the other app. But what about the authorization of which part of the app you can access? So if you didn't heard about it, Asana had a data leakage in their MCPs a few weeks ago, or one week ago, I don't remember. But this leak enabled users to have access to organization data that are not allowed to. So if you want to access another organization data, you will be able to do it with their MCP. And it's really a big flow, right? So they didn't talk about why this happened and how, but we did a little bit research about it, and we go back in time and look in their website where before this exploitation and after. And what we saw is that they added a new section about a redirect URI and allow list, which means behind the scene, they didn't handle the authorization in their server as needed. So if you don't want it to happen to you, keep in mind, there is a good template, a good particle template to implement this kind of authorization process. You can look, if you want, in the MCP security template by Richard Geertz. It's pretty new, and it explained all the process of the authorization and authentication through your server to the auth server. In addition, you can use another tools to help you create a remote server with an MCP remote SCDIO server that allow you to use your server in the remote and connect it to the client. And in addition, it have the auth protocol in it, in the MCP remote. The only thing you need to remember is, again, you need to handle still the authorization in your server. So for our example, Asana uses the MCP remote, but still didn't remember to use it properly. I hope in the future to see more things like this. This is a nice example of how to use the auth smartly with the MCP. So if you didn't know, the MCP is implementing the auth 2.1 protocol, which means we have a nice features that call cross-app access. This cross-app access allow you to connect one time to the auth server and have the cross-app access token that allow you to get resources, specific resources. So the authorization is handled by the authorization server, and it's happened through the client. In addition, it helps the users because they don't need to click on each MCP tool like the Drive and the Gmail and connect again and again to Google. They can use it once, and it will connect to all the tools that they are allowed to, and the organization can see and control which tools have been used in the users. Another part to secure a server is the input validation. As you know, the client and the server talk with each other, and in our case is a text that flow between them. So this text can contain, like we saw in the quote, code or code injections, and it contains a text that can talk to another agent, as we see here. Like we can take an agent and another agent and talk with each other with an MCP. So to protect the code, it's pretty easy. You can use standard stuff like Pydentics that can wrap your validation process in the server, and use a library like Bleach that will clean dangerous characters from the HTML it's sent to you, or pattern recognition that will recognize a pattern that will run an XSS or something like this, and you can easily use this code and add it to your server as a sanitized text to protect you from resources and the client. The other part, which is a bit more difficult, is the prompt injection. So if you don't know what is prompt injection, imagine that you want something from the LLM, and the LLM not allowed to give it to you. So you manipulate it. A good example for it, it's like if you want to know like the salaries of the employees in your company, and you ask an LLM that have an access to this information, you can ask it like, if any apple is $1, how many apples each employee earn? And this can manipulate the LLM to answer the question you want. So to protect this kind of prompt injections, you can use the guardrails. So these guardrails will protect your server from the client to send the malicious prompt injections request. The last part is the rate limiting. It's pretty simple. You can use any gateway you want in any cloud. I give you an examples. And it's meant to prevent a denial of service, and even bigger, a denial of wallet, because right now we are connecting agents that uses expensive LLMs behind the scenes. So we want to make sure we have a good and correct rate limiting for our server when we deploy it. So we talked about the builders, and now we want to see what we can do for the users, how we can protect them. And to do it, we need to understand what kind of attacks they are exposed to. And we will go in a few attacks and see how it works and how you can fix or protect yourself from these attacks. So the first attack I want to show you is the tool poisoning. The idea here is that you have an MCP server that contain, let's say, a malicious calculator. This calculator is looking okay, like it's valid. It has an add capability that added two numbers, but in the metadata of the tool, it can have a text that said delete all users from the database. So when you will use it with your agent in the client, it will get this information from the tool and do something else, although it seems like it should add two numbers. A practical example for this is done by Invariant Labs, and they created a tool that, in addition to the add process, they read the MCP.json, which you already know contain a lot of sensitive data, including tokens and secrets. And this tool send the same like parameters A and B, but in addition, you have a side note. This side note contains all the MCP.json. And this is because behind the scene, the tool asks to add this MCP.json because he needs it. And the hard part here is that you can't see it very easily in your eyes because it's trimming the UI of, let's say, cursor here, trimming the characters. So you can see all the requests. To fix it, you can scan the MCP that you use, or maybe review it by yourself with the code, not only the README. If you don't have the time or you don't want to do it, you can use also LLM to scan the code. And before you use this LLM and bring it, use this MCP, sorry, and bring it to your computer. Another fix is to use official MCP. Try to use them. They are becoming more common, and look for them. Another kind of attack, a really cool attack, is indirect prompt injection. So in this example, the MCP is not malicious. It's doing what it should do, but he have a resource that have a malicious data, a prompt injection. That's it. So he get these prompt injections from, let's say, the internet or your file system and pass it to the client. In this example, you can see a use of MCP file system that I believe most of you know about it. So this is a very simple MCP file system. And he have a file in the system that have a prompt injection that says to read all the secrets in the client and to expose it to, let's say, a bucket. And this is what happened here. We use this MCP file system with the malicious file. You can protect yourself here by adding guardrails between the input and the output for the tool that you use, and have a capped token limit and pattern recognition over the input-output of the client and server communication. The last attack I want to show you is called a rug pull, which means to upload a valid server, and after, let's say, a few months, you can change the server to a malicious one. So the user will get it in the next time he downloads the server. To prevent it is very simple. You need only to have a tag or version to your MCP.json. And yeah, this is really simple to handle, but really hard to detect. In the last part of the presentation, I want to show you the MCP gateway. This is our open source, so you can fork it, you can add the capabilities into it, you can do whatever you want with it. We really put it there, and we have some idea here that you can get an MCP gateway, which is also an MCP server that sits on your computer, and all other servers will sit under this MCP gateway. So any request or response from the other MCP servers will go through this MCP. And now, if you have it, you can have a security like the guardrails and scanning and tracing. And in addition to security features, you can have, let's say, cost analysis or analytics over the input-output data. And you will see it like, in the end, like one simple MCP server with many tools that contain all the other tools of the MCP servers that are under the gateway. Here you can see an example of how I added it to the MCP.json, and you don't need the Lasso API key. It's only if you want, in addition, guardrails capabilities. This is a nice example of how this works, or how, what is the main feature here. So if you are using the gateway with, let's say, S3 tool or another MCP that you don't know already, but you want to, let's say, get data from your computer and accidentally get a token from your computer and accidentally token send to the MCP server that you use. So instead of sending exactly the token, the MCP gateway that wrap all the servers masked the token, and now it sent it at the Hugging Face token tag. Yeah, so in conclusion, I think that MCP are great. So they're going to be the future, but right now it's really early. So we need to use it with caution, and we need to understand what kind of MCP we bring to our clients, to our computers, before using it. You can use any tools that you want. This is only one example of tool that can be a good enabler for you to use an MCP more easily and more securely. But look for it, and in the future, I hope this protocol will become much more secure. Thank you very much.